this experiment, we are going to map the electric field lines between the two opposite charge points called a dipole. Dipole is the system of two charges. One is minus, the other is plus, and they have a certain distance in between. Of course, because of the charges, they will create some electric field distribution around. Now, experimentally, we will try to draw these electric fields by using the methods of equipotential lines. In this experimental setup, a carbon paper is used. There are two conducting regions on the paper. The conducting regions are connected to the positive and the negative terminals of the power supply. The multimeter will be used as voltmeter to determine points having the same potential. After finishing the setup, as soon as the power supply is turned on and some voltages are given, this will create a positive charge over here and create a negative charge over here. Since the carbon is conductive medium, even so it's a pure conductive compared to metals, its conductivity is enough to have or create electric field lines on it. Since the electric field lines is not observed directly, the points having the same potential, which will allow us identify equipotential lines that you need to use to obtain electric field mapping, are started to search for. For this purpose, one of the probes connected to multimeter is put a fixed point on the horizontal axis of the paper. The other probe is moved on the paper to find the point having the same potential with a fixed point. Zero value on the display of the multimeter is observed at points having the same potential with the fixed point. 3 points on both sides of the horizontal axis having the same potential with the fixed point should be found, and the procedure for 5 more points, 3 on each side of the origin, should be repeated. In this online experiment, we are sharing with you the data have collected in the laboratory before. In the experiment file, points having the same color are at the same potential. You are supposed to draw the equipotential lines by using these data. After drawing the equipotential line, using the information that electric field curves are the curves connecting the charges and intersecting orthogonally with the equipotential curves, you should map the electric field lines. After that, you can go to the second part. Another carbon paper, including a conducting ring, is used. This time, only the points around the conducting ring is examined. A fixed point is chosen around the ring. One of the probes is put on this point, and the other is moved around the ring to determine the points having the same potential. We are sharing with you these data to draw the equipotential curves by using these points and determine the electric field curves accordingly. Please use the report template given to you when you prepare your reports.